Alright, what I have for you today, as you notice, is a work and energy problem combined. Okay? So we've got a sled, 80 kilograms, sliding down an incline. The incline is 20 degrees, and the total length of the incline is 50 meters. Okay, the braking force is 20 newtons. Okay, so at all times, whatever the small amount of friction you think in sled on ice, there's not much. Let's call it 20 newtons. The question is, what is going to be the velocity of the sled when it reaches the bottom? Now, you could do this with kinematics. All right, do like, okay, force, we find the normal force, we find the force parallel, first perpendicular, etc., etc., etc. Find the acceleration, find the distance, etc. Works out. But you can also solve it with energy, and that's what we're going to do today. Okay, so the first thing we need to know is that, remember that work is the change in energy. Okay? We also know that the energy initial plus the work equals energy final. Okay, because work is the only change in energy. Other than that, the energy is not going to change. Energy is conserved. Work is the transfer of that energy into some other form of energy. So we have our kind of, sorry, I should write this mechanical energy, just to be clear. Okay, so now we have to calculate our mechanical energy and our work. So, mechanical energy initial is going to be 1/2 mass initial velocity squared plus mass times gravity times the initial height. Okay? And that's going to come out to be 1/2 times 80 times 0 squared plus 80 times 9.8 times 50 sine of 20. We want our height, our initial height here. Okay, for our initial height, we can't use 50, we got to take this. Alright, and so we're going to use 50 sine 20, and that comes out to be 13,407. Huh? Joules. Put units on there, joules. Alright? Then we calculate work. Work is going to be easy to calculate this time. We've got force dot distance, or force distance sine cosine of theta. In this case, that's the force is 20. The distance is 50. And theta is going to be 180. Okay, our distance is this way, and our force is going to be that way. Force of friction is going to be that way. Okay? So, we get cosine of 180, and it comes out to be negative 1,000. Okay, again, negative 1,000 makes sense because we lose energy to friction. Alright? So now we're going to put it all together. I'm running out of chalkboard today, so I got to start writing smaller. We have, again, coming from this equation, 13,407 minus 1,000 equals mechanical energy final. So 12,407 equals 1/2 mv final squared plus mass times gravity times h final. Okay, h final is 0, so we get 12,407 equals 1/2 times 80 times v final squared. We solve that to get v final equals 17.6 meters per second. Okay, and that's the velocity of the sled at the end. This is due to, again, change in height. All right, there you go.